Okay, we're going to look at sine and cosine functions. So first off, let's look at our mother functions. So I'm going to look at my unit circle here. And remember that if I have a triangle, this ordered pair x comma y, the x values is equal to the sine of theta, and the y values is equal to the cosine of theta. So sine is the height, and cosine is the horizontal distance. So for my x's and my y's, actually, you know what? Let's do this as theta and my output y, okay? Oh wait, no, just kidding. Let's do x since x is in my equation. It doesn't really matter, okay? So x is like time. So when the angle is 0 radians, when it is 0 radians, I am at 0 height off the x-axis. At pi over 2 radians, my height is 1. At pi radians, my height is 0. And at 3 pi over 2, my height is -1. And then when I move back to 0 over 2 pi, my height is back to 0. So I'm going to go ahead and graph that. We always graph these trig ratios in kind of quarters. So let's split this up into even quarters. All right, so my one full cycle of one full rotation around the circle takes 0 to 2 pi seconds and then I'm going to cut these up into quarters. So pi over 2, pi, and 3 pi over 2. And sine starts with a height of 0 at 0. We're going to go up to 1 and down to -1, to 1, back to 0, down to -1, and back to 0. So I start on my circle up to the highest point, to the lowest point, and the midline. I can extend this going backwards if we spun backwards. So -pi over 2, -pi, -3 pi over 2, and -2 pi. So lowest point, so it's been to the lowest point, the midpoint, the high point, the midpoint. Lowest, mid, high, mid. Like that. Okay? So a big thing here is that sine starts at the center point, the midline. Okay? Cosine is the horizontal distance. So that's our x values. So if I have my circle from the center at 0, my radius is 1, so I'm 1 unit from center. When I go up to 0, or to pi over 2, I am 0 units horizontally from center. When I go out to pi, I'm furthest away from the center, but on the left-hand side. And back to 0 at 3 pi over 2. And then at 2 pi, back to 1. So we're going to start at 1, go down to -1. So that's 2 pi, I have 0. We're going to split 2 pi up into quarters, so pi over 2, pi, and 3 pi over 2. So we're going to start at the furthest point from center, the midline, center, midline, center. Something like that. And we can extend it going backwards. But this time we're going to go midline, low point, midline, high point. Okay? And this graph continues on forever. So the domain of cosine is x is equal to all real numbers, and the range is y is between -1 and 1. Same with sine. The domain is x is equal to all real numbers, and the range is y is between -1, and 1, with the 1 and -1 being included. All right, a couple of things about our equations. They're just like every other equation we've done. Right? There's a mother function, a general equation for sine and one for cosine. The amplitude is the vertical stretch. It's also the radius of the circle. Okay, the period is 2 pi over b. It's basically the time it takes us around to go around the circle. The k value is the midline. It's also the vertical shift. And then for our horizontal shift and stretch, we're going to use these equations. So we'll know where the cycle starts from by using bx minus c equals 0, and we'll know where it ends by using bx minus c equals pi. So we're going to graph 2 main points, and then we're going to clearly label we're going to graph 2 full periods and clearly label 5 points and or asymptotes depending on the graphs. So for 3 cosine 2 pi, I'm going to just go ahead and label in my a value is my amplitude. So my amplitude is 3. The midline is plus 0, so 0. The period, my b value is 2, so I'm going to take 2 pi divided by the time, which is 2, or the speed, which is 2. So I get my period is going to be pi. So we're going to have a full cycle in pi units. And the left side starts at 2x, so anything inside the parentheses here, 2x, or 2 theta. So anything inside the parentheses. And we're going to set that equal to 0. Solve for 0. Theta is equal to 0. So that's my start. And then we're going to take 2 theta and set it equal to 2 pi. I'm going to go ahead and divide. So theta is equal to pi. So a full cycle happens between 0 and pi. So I'm going to go ahead and graph in my quarters. I start at 0, and we're going to end at pi. And then what's a quarter of pi would be, so pi cut into quarters is pi over 4. So I'm going to count it by pi over 4, then 2 pi over 4, which is pi over 2, then 3 pi over 4. And we can count pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. And then, so this would simplify to pi over 2. This simplifies to pi. And that's what I'm going to graph in as my units on my circle, or on my graph. Okay, so our midline is at 0, so I just go ahead and give myself a little dashed line for my midline. And then my amplitude is up 3 from the midline. So our radius reaches all the way up to positive 3 and down to negative 3. So I like to graph in my midline, my plus 3, and my midline minus 3. Okay, minus the amplitude. So cosine starts, does cosine start at the midpoint or the high point of the graph? It starts, remember, at the high point of the graph. So we're going to go ahead and go the furthest from 0. And then it goes back to the midline, down to the lowest, back to the midline, and up to the highest. This here is one full cycle of our graph. We're going to have to graph in one more, so I'm going to work backwards. Negative pi over 4, negative pi over 2, negative 3 pi over 2, and negative pi. And then I'm going to go ahead and say midline, lowest, midline, highest. Okay, 2 full cycles. Okay, next. All right, where's our amplitude? Our amplitude is the absolute value of negative 2 here, which gives us 2. Our midline is a positive 1. Our period would be 2 pi divided by our b value, which is pi over 4. I'm going to go ahead and clear my denominator by multiplying by 4 over pi. My pi's cancel, giving me 8. That's rad. Okay, it's nice because now we get to count up by whole numbers. So inside the parentheses, we're going to set that value. Pi over 4 theta is equal to 0, and pi over 4 theta is equal to 2 pi. I'm going to go ahead and multiply by 4 over pi for all of these. Wow, that took a long time. Sorry. Okay, cancels to give me a 1. So theta is equal to 0, and theta is equal to, pi's cancel, 8. So our starting value should be 0. Then we're going to count up by quarters. We're going to take our period, which is equal to 8, and then we're going to cut it into quarters, so into 4. So we need to count up by 2s. So our starting value is 0. Then the next tick mark will be 2. We're going to add 2 to give me 4, then 6, then 8. So 0, 2, 4, 6, 8. I like to go backwards, so -2, -4, -6, -8. And then our midline is at 1. I'm going to graph in my midline. My amplitude is 2 up from the midline to 3, and 2 down to -1. All right, so I have a sine function. So we're going to go back up here. Does sine start at the midline or the high point? It starts at the midline here, okay? So at 0, we're going to start at the midline. Whoa, okay, at the midline. And then it spins up to the high point, down to the midline, to the low point, and back to the midline. So now reverse this. We're going to go down to the low point, to the midline, to the high point, to the midline. Whoa, things got crazy. Okay, last one. So a sine function, again, it starts in the midline. Our amplitude this time is 1. Our midline is at -2. In our period, it's 1 theta, so 2 pi divided by 1 gives us 2 pi. This time, we need to take our middle part, our input part, theta minus pi over 2, and set it equal to 0. And theta minus pi over 2 is equal to 2 pi. So add pi over 2. So theta is going to start at pi over 2. And then it ends at, add pi over 2. So we get theta is equal to, and this would be 8 pi. 2 pi is 8 pi over 4, which leaves us at an ending point at 9 pi over 2. Okay, so we're going to count up. I'm going to count by pi over 2s. 1, 2, 3, 4, 5, 6, 7, 9. So this is pi over 2, 2 pi over 2, 3 pi over 2, 4, 5 pi over 2, 7 pi over 2, 9 pi over 2. And I'm going to go ahead and take my 2 pi, split it into quarters, which gives me pi over 2. So I start with pi over 2. I'm going to add a quarter, which is 2 pi over 2, 3 pi over 2, 4 pi over 2, and 5 pi over 2. I did something wrong here. I see exactly what I did wrong. I added quarters instead, so let's go back to this guy. And I need to change this to 4 pi over 2, because that's 2 pi, which gives me, instead of 9 pi over 2, is going to give me 5 pi over 2, which means that that's my ending point, and that makes a lot more sense. Okay, so let's go ahead and graph in our midline at -2. Our amplitude is 1, so I'm going to graph up 1 and down 1 from my midline. So this is my mid, my plus my amplitude, and minus my amplitude. And then I am going to start at pi over 2. So the midline at pi over 2 goes right here. So this graph has been shifted to the right. This is basically right pi over 2. Okay. Then we're going to go up to the high point, to the midline, to the low point, to the midline, to the high point, to the midline, to the low point, to the midline. And there is 2 complete cycles right there. Good thing I made a mistake. It helped me graph in the end. Okay. And that is it for right now.